In the last section, we spoke about some ways in which we might be able to increase the accuracy of our k-nearest neighbor algorithm. Now, before we try to implement any of these changes right here, there's one quick thing I want to mention. At present, in order to gauge the accuracy of our algorithm, we have to flip back over to this little tool. We have to drop a whole bunch of these balls to get some data points, and then we can finally click Analyze and get some console log over here that tells us some result. So that is definitely kind of a laborious process to go through to evaluate whether or not making any of these changes is actually worth it. And so before we try to tackle any of these changes right here, we have to first have some way of comparing accuracy, some like rock solid, concrete, apples to apples way of comparing the accuracy of our algorithm given changes to any of these different inputs. So before we make any of these changes right here, we need to first invest a little bit of time to get some better method of recording exactly how accurate our algorithm is. Not only for some single data point, like some single ball drop at 300, we need to have some way to compare many different positions and say that if we change the value of k from, let's say, 3 to maybe 5, that is going to increase the accuracy of our algorithm for any possible drop in here, and not just dropping the ball at exactly 300 pixels. So let's talk about how we would do that. How can we somehow record the accuracy of our model, or get some accuracy of our model, over many different positions? Well, here's one way to do it. So we're going to record a bunch of different data points. So we're going to essentially use that little feature to drop a lot of balls at the same time all over the place, like so. Once we get a whole bunch of data, we're then going to split all of our data into two separate pools. We're going to call one set our training set of data. So that might be this set of data over here. And then the other piece might be our test set. And this is going to be this other piece over here. Then for every single record inside of test, we're going to run our k-nearest neighbor algorithm using our training data. So in other words, we're going to take off this first record right here. This first record has a drop position of 10, and the ball fell into bucket number 1. So we're going to run our KNN algorithm using this training data, and we're going to try to predict the bucket for a drop of position 10. If we then get a result of bucket 1, we would say that, okay, that's good. That is a positive result. Our algorithm was accurate. If we do not predict bucket number 1, then we'll say, nope, totally wrong. We might be able to improve this a little bit. We'll then throw away that record, and we'll go on to the next piece of test data right here. So we'll then run KNN again for a drop position of 137, and we'll see if it predicts bucket number 2. We then throw that record away. We move on to the next one, run it again for 323, and try to predict bucket 2, and then repeat the entire process over and over again until we eventually exhaust all of our test data. So the idea here is that we've got this pool of data where we know exactly what bucket the ball went into given some drop position. And so we can very quickly have some set of data that we can test over and say pretty confidently that if we make a change in K, or if we introduce some new feature to our data set, or we change anything else there might be as inputs into our algorithm, we'll very quickly know that this is an improvement for all the different variables inside of our algorithm and not just like some single data point at just that 300 pixel part. So that's the idea. That's what we're going to do. We're going to split into training and test. We'll then run our algorithm many times and try to summarize and report those results and print out some total accuracy. So let's take a quick pause right here, and we'll start writing the code for that in the next section.